Okay, I think it's time to start. I know it's the last session, so thank you for coming for this talk, and I'm happy that there are so many people to listen to my talk. And as you can see, I will talk today about how to do scheduling in a distributed systems, and especially with the applications that are written using Spring. My name is Marek Jeszka. I'm coming from Poland, but currently I'm working for N26 in Berlin. We have also office close by in Barcelona and pretty fresh office in Vienna, so the company is growing a lot. But also we do, of course, some interesting technical things, and this is one of the topics that I want to cover. So let's start and look what's the agenda for today. So at the beginning, I will talk about the background, about what kind of process we wanted to solve and why we introduced this one, what you will see soon. Then I will show two different approaches, because we believe that usually the problems should be solved in an evolutionary way. So we usually try something simple, we check if does it work or not, and then we move on if there is a requirement to improve that. In the meantime, and also at the end, I will show a few results, what did work, what didn't, and what are the conclusions, and what are potential ways to improve things. So let's jump into the problem that we tried to solve. Before actually going into the whole problem that I wanted to show you, let me do a short introduction of how the systems in our company are basically developed and how we try to do things. So in the past, at the beginning of the lifetime of the company, we've been doing most of the things with synchronous communications, so traditional HTTP communication. But we know that this is not the best way. We also try to handle a lot of traffic, so we do the things with the events. So this is why we have asynchronous communication in our company, and in this sense, I mean that we send events between the services, and it's not, of course, always possible. So we have still some synchronous way to handle, especially if the process, like business case, requires that there is a need to receive a response immediately. But if you can do some things in a delay, with a delay, then that's basically using events is the best way to go. Also, an additional benefit of asynchronous communications is processing that is now more reliable. So because we use AWS and their solution for streams is called Kinesis, they have this guarantee that each event will be delivered at least once to the service. So then it means that you kind of push the responsibility to the different service, to different solution, and they guarantee you that you will not lose anything, which is not always the case in synchronous communication. And also, I like the visibility that in events communication provides, because now we can have some screen on which we can display how many events are going to be processed by a service, and how, for example, how is the service, how fast it's handling the communication. So if it's falling behind in the communication, falling behind in the processing of the events. So having that in mind, that this is how we try to solve things in our company, let's look at the problem that we've been having. So here you can see the simplified view of the problem that we were trying to solve. So from the left side, we have this event stream. So in our case, it's a Kinesis stream, and we have we have some events coming from this stream. Now let's think about something abstract. An event is received by an application, and we have a component in our application which we call stream consumer. It basically reads the item from the stream and filters out the events that are important for the service, because there can be, of course, different events that are not important for our application. And what we do is we store each event into the database. Each important event for the service we store into the database. You can ask why we are doing this actually, why the database is needed. We believe that reading the stream should be as fast as possible. So storing all the events that we want to process into the database make the process that the consumer that reads the event from the stream kind of fast. And if there would be some logic needed to process the event, it would take time. And in this case, if we store it into database, which is usually super fast, then the stream consumer can move forward and can process each events. So this is how we improved the way how we process the stream, but also now we can store the data into the database, and if the same event will be received for the second time, that can happen, then now we have a source of truth. Okay, we stored this event, we don't need to handle it again, and we can move on with the reading of the streams. And the second part, on the right side, there is a scheduler. So there is this job that I will be talking mostly during this talk, that we read something from the database, the events that are stored there, and we process them, maybe perform some logic. Now is the time for performing the logic, because we didn't do this on the streaming consumer, because that was just fast. And when we process this, we need to store this into the external service. So basically, this is the use case. Event is received, and we store this into an external service. So let's look how this can be done in a Spring application. So probably this is a part of code that most of you already written, or at least seen it. So we have a simple service. We mark it with an annotation component. So now Spring can find it, and the service can be injected into the different components. And we have a method that runs quite often and processes the events that we have in the database. And we can mark it. Okay, it's now we want to have it quite often. So we mark it with another annotation available from the Spring, and we say, okay, let's run it that often as the cron expression said. So cron expression is probably also pretty known for all of you, but it's just an expression coming from the Unix environment, and you can basically define how often something should happen. And in this case, the first digit, the first position 0, that just says that when the clock arrives to a time that has 0 seconds and any other number is just different, just any, it should trigger. So basically, it will trigger every minute at the 0 seconds of clock. But as you can imagine, this simple solution works only when you have one single machine. And in our company, amount of customers and amount of traffic in the system is really high. So we need to scale. We need to make the application grow. So this is why we have to talk about distributed systems. And in distributed systems, there are two ways to scale. The old one, called vertical scaling, so going up, it means that you basically make the service that is handling the traffic much stronger. You add CPU, you add memory, and makes it much stronger, and now it can handle more traffic. But actually, when you go with this solution, everyone probably understands that this doesn't work, especially in the cloud, where you have a limited amount of servers that you can buy. And there is always the best server you can buy, and it costs a lot of money, but it's still maybe at some moment not efficient enough. So we can say, okay, vertical scaling actually doesn't scale. So the other way to go, of course, is the horizontal scaling, so moving left and right and adding more nodes of the same machine. And probably it's pretty known in the community why we do this, but let's name few benefits. First, cost efficiency. Usually, few nodes, much smaller ones, much cheaper ones, perform better or at least the same as one big machine. So this is the first benefit. Another one, high reliability. We have multiple nodes. One goes down, the other can handle the traffic. Also, easier to expand, of course. We have 3 nodes. Why to not add 3 more, and just load balancer will handle the traffic. So having that in mind, let's look at our problem. So our problem was that we had a scheduled job, and now we want to run it on now it would run on multiple nodes, which is usually not what you want to achieve. So this is why we had this problem: how to run this scheduled logic on a single node. And why? Because you don't want to repeat up also from the resource usage, but also maybe the business case just doesn't allow you to repeat. To solve this problem of running on a single node, you need to have 2 information, or like two problems to solve. Because we have now multiple nodes, you have to select one that will run this scheduled job, and you also need to have this information stored somewhere, because the other nodes need to know, okay, I'm not longer the node to run the scheduler, so I will just go over and sleep more. So let's look at the whole system, how it could look like. So we have 3 instances, let's say for the sake of example, and the instances actually could communicate between each other, and they could say, maybe we can agree on between us that one of us should be a leader. But the approach in Spring, and I suppose also in other frameworks, is that the nodes are pretty stateless. So basically they are alone, kind of standing, and they don't even know that there are other instances handling the same. And if you would think that they should know, then comes to like network, how they communicate. If you have different virtual machines, maybe you have different Docker containers, so how they can communicate, is this the same machine? Maybe it's a different network. So to simplify, let's say the communication between these nodes was not a case for us, especially if we wanted to provide something fast and have a simple solution that would work. So we didn't go this way. This is why we introduced some other solution that will basically solve it for us as an introduction of another component. So this is why we thought, okay, now we need a place that will store this information for us. Let's call it, it could be a cache, it could be a database. I've heard during the conference that people were solving this with Mongo. It can be different solutions, but basically this place has to be reliable, of course, because we don't want to introduce more failing points. And it will basically do 2 things. First, it will store the information, which node should be a leader, but also it will allow this communication between the instance and the orchestrator, as we can call it differently, and provide the answer to a question: am I a leader? Is the instance that has been just triggered by the cron, by the schedule to run to process the events, am I a leader? And only if this node will receive the answer, only then it will process the events in the database. So having that in mind, let's think how we could solve that. So coming back to the original question, because we are in a Spring-based application, so to specify it even more, we have multiple nodes. All the applications are Spring applications, and we want to select one as a leader. And let's look at the code again. So we had this simple service already visible here, and it was working. And now let's see how it can be done in a distributed world. So we've used already one annotation, @scheduled. So maybe we can use another one, this time our custom, and let's name it runIfLeader. So in this sense, we have now a method that is pretty clear, right? If you look at it, okay, it does some scheduled job, but only if the node on which this code will run is a leader. So let's move into the details, how this can be implemented. So writing your own annotation is pretty simple. It was visible on many talks today and yesterday, but actually no one, at least I didn't hear, no one went into the details. What's these 2 properties that you need to add to that interface? So it's called interface, but it's just a nomenclature on the Java that you need to create a class with this add interface. And you basically need to provide these 2 properties. The first property is a retention. It basically tells to the Java JVM or compiler where this annotation should stay. So the retention that we've used here is the runtime. So basically it says that this retention should stay for the whole lifecycle of the application till the runtime. So let's say compiler could remove some annotations, but this one, no, it has to stay till the lifetime, because in our case, of course, if it would be removed by the compiler, how running code could check if the node on which we are running something is a leader. So having that in mind, the retention is the first, target is the second one. Target is simple, it just marks that says where you can put this annotation. And for us, it's a method. So it could be a class, but of course, this is what we want to have. Okay, let's go deeper, because this is just an annotation. And now we need to somehow understand how this annotation can be understood by the Spring. So this is why we need to introduce aspect-oriented programming. So aspect-oriented programming is just a name, but basically what it says is that an aspect is a concern that cuts through the whole application. So a concern that is attached to all the, it could be attached to all the business logic in the application, next to the database, next to the service, next to the controller. So one example that is pretty commonly said when someone explains AOP, it's logging, because logging is something that we do every day and we put it on every part of the application. So this is why it's a cross-cutting concern. Also commonly named here is transaction management. This is something that we do in different business processes, so it's not something that is attached to a specific problem, also cuts the whole application. How we can, having that in mind, how we can now enable that in the Spring? No surprise here, we just add new dependency, so Spring Boot Starter AOP, and now Spring can find our annotations and can process them. Why it was done like that? I suppose the authors of Spring thought, okay, maybe we can enable people to introduce their annotations, but it's not something that common. So the core Spring doesn't have this. So you can use, of course, annotations, but if you want to create your own, you need this dependency. Okay, that would work. That could enable the application, but how actually we can really teach Spring that there is an annotation and what it should do? To understand that, we need to introduce the concept of advices. So there are 3 advices. There are actually more, but let's focus on the 3, the most simple ones. So advice is a concept of saying, please, on the runtime, process this annotation at a specific moment in time. And in our case, it's a method. So we say, maybe this advice that we will write, that will check for us if the node is a leader, could run after. So for us, of course, after is already too late because the job would perform, so we can cross it out. So maybe before could be used for us, but before is an unconditional one. So before advice says this code will run. Whatever happens, this code will run, and we can add some logic, some code before. For example, log. So logging could be also handled by aspects, and you could say before this method always log. But unfortunately, it's unconditional, and in our case, we need to use around, which adds this possibility to proceed only when a specific condition is met. Let's look at how finally we can implement this advice. So how we can use this advice. So to have this, we have to create our own aspect. And originally in Spring, the aspects were defined in XML. And probably most of you don't use anymore that, so we can use annotations. Annotations are coming from AspectJ framework. So this is why you can see these 2 annotations, aspect and around. These 2 are coming from this framework. And basically, when you have this method, this class here, you need to create one method and annotate it with one of the advices that you've seen on the previous slide. And inside this around, you basically define how it should match. And first, what you can see on the slide is that it has to match the annotation with the name that we've defined a few slides before. And it also has to match an execution of a method that returns nothing. This is why void. And it has any name and any list of parameters. Okay, so now this one will match the annotation that we will put on a specific part of the code, but the logic has to be inside. This is why we need to introduce the last part of AOP to close the whole topic of the annotation. We need to have the join point. And the join point is a point in the code when the application runs. So the application runs, executes something, then it's a point, and then something next runs, etc., etc. And before our code will run, there will be a join point just a moment in time before running it. And this is when this annotation will kick in. And as you can see in the code, that we will basically check if this node is a leader, we only then proceed with the join point. And in the other case, if not, then we will just will skip the execution. And again, here, I will not go too much into details regarding the leadership, how it is selected, how it's implemented, because it depends on the solution that you selected. So in our case, it was a node that we could basically use an HTTP call, but it could be wherever else you decide to use there. Okay, so having that in mind, that solved the problem, it was working for us, but we found out that there were a few things that we didn't like it. So let's talk about the disadvantages of this solution. First thing that I want to mention is the separation of business logic and the scheduling logic. So as you saw on the slide, we have this add scheduled annotation just above the method that does something. So someone would say that in solid principles, when you have a single responsibility principle, you shouldn't mix that. We agree on that, and we thought that maybe it could be solved better. Also, we found out that it was not that easy to test. So we have this annotation, but writing a simple unit test verifying that this part of code is scheduled and that this part of code will run that often as we want was not obvious. And the last, we found out that when the application started to grow, we had more and more jobs scheduled, and it became a little bit mess because the jobs were just spread through the application. And if someone would like to verify what are the tasks happening in the background, it's not that easy. You would need basically to search through the whole application. I want to also talk, before switching to the second approach, I want to talk about one specific problem that we had with this solution. So we also use from the AWS cloud, there is a queue solution called SQS. And this queue can be used with a client provided by AWS, and the client inside there uses this as @SQS listener, another annotation. Everything is annotations. Having that, we could implement something like an onEvent method that you have here, and you can basically see that definition of that is pretty easy. You just say, okay, this is the value, in this case name of the queue that you want to listen to, and this is the deletion policy when something should be removed from the queue. This on success means that if the method proceeded without any exception, it was all good, so now the message can be removed. And how this is working is that the node that runs this takes a message from a queue, makes it invisible for other nodes, and processes it. But in this case, the node would take it and mark it invisible, and will check if it is a leader, making it impossible to read by the other nodes. So that's pretty inefficient. And at the beginning, people were not that sure what's happening, because what could be wrong using some annotations, right? But actually looks like the order of the annotations probably should be different, and you should never read something from an SQS because doesn't make any sense to even try reading something from the SQS if you are not a leader. And if you just follow, if you are new in a team and you don't know what is happening, and you are just following other part of the codes and basically copying, pasting SQS listener, you don't go into details. Maybe you don't understand that actually the message will be not visible for some time if the check on the leader is taking some time. Okay, this is why we tried something else. We decided that maybe we should switch to another approach, which is called programmatic approach. Programmatic, it means that you need to write a little bit more code, but you have a much better control of the way how you want to schedule. So let's look how this can be done. To have this, we now switch out of the annotations, so maybe that's already a benefit for some of us, and we now need to implement an interface with the name scheduling configure that is available from this package. And this is something standard code of Spring. And having that in mind, writing that is pretty simple, because the interface just has one method. The method says it will configure the task, and it will provide you a registrar, and on this registrar you will basically call all the things that you want to schedule. And one additional benefit that I will show in the few slides. So let's look at the code, how this can be done. So this time we create a configuration class, This is why we need this first annotation at configuration. We also need to enable the scheduling. By default, Spring is not scheduling anything. The @scheduled annotation would also not work without this annotation. But in this case, when we have this one class responsible for configuration of the scheduling part of the application, it makes actually sense to put this enable scheduling here in this place and not, for example, on the main class of the application. And implementation of this method that I've already mentioned is also pretty easy, because you have this object registrar and you basically call a method. There are a few methods on this registrar. One of them is @cron task, which basically does exactly the same as we saw on the @schedule annotation. So you create a new cron task, another object, which needs 2 parameters. First parameter is just the block of code that we want to run with some scheduled approach. So we just process the events in our case. And the second parameter is the cron expression that you want to say how often it should run. So this code basically does the same that we saw on the previous with the first approach. Okay, let's look more into details how this could be improved. So we believe that in this, or what I already mentioned, single responsibility principle. So this is why we thought, okay, the processing of the events, or the definition how the events should be processed, should be in a different place. Here we are writing a class that is responsible for scheduling, but another class should be responsible for saying how to do something when the job will be woken up and asked to do something. This is why we ideally it should be, at least we think that ideally it should be done like this, that you create you inject a method, you inject an object, a bean basically, which is a runnable, but because there is a name match, it will work. You could also use, instead of runnable, you could use the proper class name that you will see soon, and then this object that you have available now in your scheduled class, you can use it inside the method that you need to override. So basically, this is exactly the same as you saw on the previous slide, but now the split is much clearer. And the class that we need to schedule, the job that we need to schedule, can be defined now in a different component, which is a task for us, and we just say, okay, it has to implement a runnable interface because it requires to run something. So this is why you run the code inside this one method that you need to implement. Okay, having that, we can move on and see what are the benefits of this approach. So first, we already saw tasks are now scheduled in one place. We have one class, everything is inside. New person comes and see clearly, okay, these are the tasks that we are having. It's pretty easy to understand what's happening in the background. The additional benefit is a custom executor service. This one was completely not discussed on the first approach because there is no way to handle that. Only with programmatic approach, you can create your custom executor service that should run the tasks that you have in the background. And when the application grows, maybe you have a lot of tasks running in the background, especially tasks that take a lot of time, and maybe you need multiple threads to process these tasks. And with the @scheduled approach, with the first approach, there is only one thread. So if you have this problem, basically you need to switch to a programmatic approach. Let's look how this can be implemented. So now we have this registrar again configure task method that we need to override. And now, instead of calling on the registrar @cron, we call setScheduler. So now we are saying, okay, don't use the default single-threaded executor service, but use this new one that we will provide you. And again, some little bit of shuffling and putting this to a separate method, maybe also another class if someone prefers. A task scheduler method will provide you the executor service. Executor service, by the way, if you are not familiar with that, is just a class that tells how it will handle the jobs, how it will create the threads, how many threads it will have, and yeah, basically will handle something in the background. And in this case, we are creating using as executors class with a static method new scheduled thread pool. So we will say, please create for us a thread pool that will work with a scheduled items. and it will have, for example, 4 threads now. We can set it like that. And we can also, as an additional benefit, create a name for this for these threads that will be used by this executor. So here, this code is unfortunately not coming from the JDK itself. Here you need to use Guava to use this builder, but that's just implementation detail. But here, as you can see, we can create a name format for this threads, and also with the %d at the end, which means that it will be a different number for each of these 4 threads. And when you will do some debugging or checking on the live application how is the things happening in the background, you can see in the logs that this is actually happening in the scheduled process. So this gives you a little bit increase on the observability. Having these 2 benefits in mind, the another point that I would like to talk about is the convenience of testing. Previously, we didn't look at the tests at all. We didn't have anything there. This is why I didn't want to discover anything of that. But here, we actually can do pretty good testing. So now we could create a scheduled config test, a class that will basically test if this is what we want to configure for scheduling. This is how it could be done. So I'm here using a traditional approach, so the Mockito. I'm saying on the first line that this test should run in a Mockito JUnit runner, so we can use mocks. And the class that is under test is, of course, scheduling config. We are marking it that it will be possible to inject mocks on this class, and we need 2 mocks to have it verified. The first mock is the registrar on which we will put on which we will call all this logic that we want to schedule, and the second part will be the task that we want to actually schedule. And the simple test that would verify that everything is scheduled as we want would just call this configure task method, passing by this task registrar mock. And at the end of the test, we need to, of course, verify something. And what we will verify is just we will check if on this mock a method add_cron_task was called, and basically if on this method these 2 parameters were passed. So this first parameter will be matched by the class type, and the second will match basically by the string. And now, if someone changes the cron expression because, I don't know, typo or whatever, now this test will verify that it's what we want to have. Another test. So we introduced the new executor service, and this one also can be tested. This is the power of programmatic approach. You need more code, but you have much more control. So here again, Mockito runner to use the mocks, using the same class on the test, injecting the mocks. And here we need only one mocked class because we will use another trick. So in the test, before running the test, usually it's the time for preparation of the test. So in the preparation phase of the test, we will create a captor. A captor is a type of an object that can check if something was executed with these parameters that we can verify at the end. And we are just creating a captor for a class that we want to check. So we know that we are expecting a scheduled thread pool executor. This is why the for_class parameter is used with this in this case. And again, testing the code, you need to run it the same as on the previous test, configure task, and passing this mock. And at the end, we verify and assert. So first, what we need to do is actually capture the value into the capture that we defined at the beginning of the test. So we are saying, OK, please verify that this mock was called with the method setScheduler, and this argument was passed there. And in this sense, it's only a captor. And only having that, we can assert that this captor contains a value. This is why we're calling getValue. So we are taking the value from the captor, and we are asserting that the value that was passed there has a core pool size equal to 4. Again, additional benefit if someone changes the pools or maybe remove the method out at all and making this scheduler a single threaded as the default implementation, this test will find it. Here, we are finally back to the original problem. Original problem, as you remember, we had multiple nodes, and we wanted to have a single node that when it wakes up, it tells us that, okay, this is the node that is the leader. So as you can imagine, having the full control of the code, we don't need to add any annotation, any magic that is somewhere deep in the code. We just can write the code inside here. This is why when you add a cron task on the scheduler, on this registrar actually, you just pass into the executable that is inside the first parameter of the cron task. You just can do whatever you want there. So you can just do this condition if it's leader. Again, now I want to show you a little bit improvement, how this can be done in a more like Spring way. So this is why we can introduce two other classes that can separate all the logic into different parts and keep the responsibility separated. So here we say, okay, this is a scheduling config class. So this class should only be responsible for the scheduling part. This is why we are injecting again here the process event task as on the previous slides. And inside the configure task, we are creating a new class, which we could name leader aware task decorator. So a decorator that will create an object above our task that we want to run, and it will check the logic itself. And only this runnable we will schedule in the registrar. So now we will have three parts. First part is the scheduling that you see. The third part is that we already had, which is the process event task. And in the middle, we have this leader-aware decorator. And this is how it could look like. It's pretty simple code, at least this part of it. That we have another runnable is just another runnable that we can pass to the cron task. And it needs a member that basically it will run it in specific condition. This is why we need this private runnable delegate. So the code that will delegate to, constructor needs to, of course, pass it to the method. It passes to the field, and inside the run method, we can now put the logic of checking how the node is a leader here, and only process the task here. And then we will just call delegate run to the last part of the whole picture. Okay, so we had this one approach, then we had the second approach. Everything was fine. It was working, but actually we found out that it's still not perfect. It's still a problem, especially when there is a network partition, or some people call it a split brain problem. This is why I want to show you this looking maybe complex, but it will be clear in a second how this problem can appear. So up to down is the timeline, how the time passes, and the lines, the vertical lines are basically the different components of the system. So we have this orchestrator, which keeps the information which instance is a leader, and we have two instances. And let's say at some moment in time, instance one wakes up because it wants to run something, and because we use this, let's say run if leader annotation or the second approach, it asks before processing something, it asks orchestrator, okay, should I proceed? Orchestrator responds, yes, you are a leader now. So instance one starts to process the event. But in the meantime, before it finished this processing, network partition happens. Network partition basically means that these two nodes cannot communicate with each other anymore. And orchestrator, how the logic of keeping the information if the node is the leader is basically keeping as open session between these nodes, and usually it requires to check if the health endpoint of the node is fine, is broken, let's say in this case, then orchestrator, what it needs to do, of course, select a new leader. So this is what happens here. The session has broken. Orchestrator thinks, okay, this node is down. It cannot be a leader anymore. We need a new one. So it selects a new leader in any way. Usually it's the oldest node, but in this case, it's not important. So it selects instance 2 now. And then in some time, a few seconds, let's say later, the instance 2 now wants to process this in a scheduled way and ask orchestrator, am I a leader? And of course, orchestrator says yes, because he's just selected it. So instance 2 processes the event and stores it into the external service. And at the end, also, suddenly instance 1 was really, really slow, but it wasn't down, also wakes up and saves this to external service. What can happen? Now we have 2 events stored on the external service. Usually, business case, you shouldn't have this case. You shouldn't allow that. So how we can handle that? How we can improve the resiliency of the solution? Of course, there is even this previous slide was maybe a little bit complex, but we can think of something much, much simpler. Let's say we have this scheduled job that tries to save something to the external service, and the response didn't come. It's just a normal HTTP call, let's say, and the response didn't come. So what the node can know, what the node can do, does it know it can repeat? If it repeat, then we'll have 2 duplicate entries, right? So can we even safely repeat? How we can make sure that the repetition will not make the whole business logic broken? We have to basically be sure that there are no duplicate entries created in the external service. And the solution to that is usually some kind of ID, which is mostly named that it's an idempotency ID. This is why we need to be sure that the action that we are performing is an idempotent. In this sense, in this case, it means that the action that we will pass, that the action that we will perform, or the item that we will pass to the external service will contain some unique ID. And having this ID, the external service can say, okay, I already processed that, so I will skip it and send it back to you a response. It's a duplicate, but no harm done. There was nothing stored twice. This is why with implementation of that, we can now say one or multiple identical requests give the same result. So now, even if you repeat it 100 times, of course, assuming that you provide the same ID each time, now the external service will be sure that it will not happen, and the previous case with this network partition will be handled correctly, because if we provide the same ID from 2 nodes, the same entry only once will be created. And because we split it, and I hope you remember from the beginning, we stored everything in the database. So this is the moment when you should create an idempotency ID. So whenever you have something to process, you generate a new ID, and when the event is being sent by any node, it uses this ID, and then this will be sure, we can be sure that it will be not a problem for us. Okay. Talking about different solutions, we also want to always talk about some improvements. What could be handled better? So first improvement that we were thinking about is that actually maybe we can distribute the jobs. If the amount of items to process is suddenly growing, maybe we should handle this by different nodes in multiple nodes basically at the same time. So first idea that came to mind to my colleagues was that maybe we can just use, we have already PostgreSQL. It's the source of truth of the events to process. So maybe we can use it to basically say, okay, this is the way how you can handle that, and this is the source of truth if the node should process it or not. And in our case, we had a PostgreSQL database, so you can use a for update clause. So whenever a node is taking something from the database to process, it can mark the rows to process that they are being taken for update. And another node, if it will go through the events, checking if the items should be processed or not, it will just skip the locked items. But here, like one caveat here, it looks good, but actually there can be a performance problem, because if you mark many rows with the update, then another node need to basically iterate through all of them and skip these. So maybe then performance will be improved, but at the end maybe it can be also a problem. So this is not discovered way to handle that. Maybe we need to think about better ways to handle that. Because another solution that we were thinking of and works in one of our systems is the SQSQ, which is a queue solution, or any other queue basically you can think of. And the SQS queue could be a source of truth of the items. So whenever the stream consumer would consume something, it would be put into the SQS queue, and it could be taken by the different instances and processed. It could work because we know, I mentioned that the instance, if it's taking it, it marks it invisible for the other ones. But here, another problem is that SQS queue is not a full database. It's just a queue, and the maximum time that an item can store in SQS is 14 days. So in the worst case scenario, when the events are really, really slow, or there is an issue in the application, or I don't know, maybe someone is on vacation and will not look on the queue, the event will just disappear. So maybe it will scale properly, but maybe it will not perform its logic. So what are the lessons learned that we had with this short session? Annotation-driven development, always with care. So looks easy, it's convenient, but you need to be aware that there are some drawbacks. Consistency of the code is for sure something that is important. We like to use the same approaches, or at least share the way that you create your bean, and then you can inject it. So having this in mind makes the code easier to maintain and easier to understand for new members of the team. And we can also think about resilience, many times here mentioned. So for example, the general idea here, kinesis, the stream, this increases resilience because we are no longer having this synchronous communication between services, but we just send events. And the predictability also grows because service now can say, okay, I process this event and I'm just done. No problem with the response that is not coming and things. And also we can think about observability, which is one example here. I mentioned this thread naming. So when you look through your logs, especially in a big application, it can be a benefit when you have a log marked with a proper thread. Thank you very much for the attention, and few minutes for the questions. Oh yeah, there's a question. The mic is coming.
Basically, I want to ask, why SQS queue and not something else? If your problem was that you cannot store the data more than 40 days.
So you think like some other complete solution, or like other queue, or what do you mean?
Yeah, I mean, yes. Why not Kafka or something?
Yeah. So I thought you mean Kafka. So in our company we don't use it yet. So maybe as a, let's say, third iteration, that could work. I agree that Kafka is a really good solution, but because we don't have it yet in our company at all, so first the problem of installing it, maintaining, and basically having this in our system, and also now people need to learn that. And yeah, because we are on AWS, we usually try to use the components that are available there. But I agree, Kafka would be probably will solve a lot of problems here.
Thank you.
How do you solve the problem when the orchestrator is down?
Yeah, thanks. Good question. So in our case, we had a solution, other solution that has that is also distributed. Basically, in the distributed system, you need to distribute everything, and just this node was also scaled. So there was no single node. So there was no single point of failure. Of course, maybe all the nodes can go down, but ideally, you want to scale it out. So there should be, if you use, for example, I know Mongo or Redis, you have some secondary nodes that can help in this case. So yeah, it shouldn't be. So maybe my picture was a little bit not in details, but basically it's not a single node. It's like a single place in the system, but it can be a few nodes that does the same and can switch between them.
So you mean a cluster of orchestrators?
Yeah, ideally cluster of orchestrator. Yeah. Or like if this is a Redis, let's say, then you have just basically a distributed database.
Thank you.
I was wondering if an ESB would help you to keep in order things in the whole process. Have you considered it?
Could you repeat the beginning of the question?
I was wondering if an ESB, Enterprise Service Bus, would help you to keep in order things in the whole process. So orchestrator, items, scheduling items, and so on.
So I have to say that I don't know. It's something that we didn't consider for sure. I don't know. There are some solutions, but maybe we are still not on this level of complexity here. That the amount of traffic is not there yet. That we need to introduce something complex. What exactly? What kind of solution did you have in mind? Could you name one?
For example, MuleSB using connectors. One connector for each task executor, and one for orchestrator, obviously clustering solution.
What's the name of the solution?
ESB, such as MuleSoft,
okay,
for example.
Okay. Yeah. So yeah, again, another improvement maybe to especially when the amount of the jobs is increasing and processing of that is high, then for sure.
Thank you.
Looks like it. Thank you very much for the questions.